Pythagoras.
Pythagoras. A theorem is a general mathematical statement that has been proven true. The Pythagorean theorem is one of the most famous theorems in mathematics. Over 300 different proofs have been given for the Pythagorean theorem. One of these proofs is based on the geometric argument. We will explain this problem.
So we've already actually proved one way. That first day when we cut apart those squares of a right triangle, we found that the two smaller ones, we cut apart the puzzle pieces and they fit into that bigger square. When we did that the first day, that was one of the ways. On this test, when we take this test on Pythagoras, if you look at this poster up here, one of the I can statements that you have to be able to do is I can explain the theorem, and it's the Pythagorean theorem. And it's going to be writing a paragraph on the test that's worth like 15 out of the 50 points, okay? And I will specifically tell you, and we will practice it, but it is using what you just did in lesson B1 and then kind of this lesson. And there might be one other method that we talk about as we go through the unit of ways that you can prove the Pythagorean theorem. So, from yesterday, what was the formula that we wrote down when we know the Pythagorean theorem? The formula was, Cassie, you ready?
A squared plus B squared plus C squared.
No. Equals C squared. And what did that mean to us? It meant that we were talking about, when we talked about that, that was leg A, right? So please write this down. That meant leg A squared. Okay? So the area, right, of A plus leg B, whatever length that was, we were squaring it. That's kind of the same as the area of square B, right? The area of square B was always going to be equal to, C was not called the leg, right, of our right triangle. We call it the hypotenuse squared. So that when you were looking at your homework, so this was really that area of square C. But that's how we did it the first day. Now, yesterday, I had some people when they did this one and they found these areas over here. Like you should have found the area was 5 of this square. And then I saw people that had their squares here and this one was exactly the same, right? So if the area was 5, yep, I'll go back. So if the area was 5, the side length, right? The side was square root 5. And you can see up on the board, I have that if we take the leg squared, square root 5 and square it, plus square root 5, and we square that, it should be equal to the square root of 10, which is what if you would have drawn this square over here, that's what that area, that's what the side length was. And if you square that, and isn't it true that 5 plus 5 does equal 10?
Yeah.
Because remember, taking the square root and squaring, they undo each other. So when you are looking at this page, and you have a squared plus b squared equals c squared, it's the area of square A, that was our leg A squared, plus leg B length squared equals the hypotenuse squared. And then I need some volunteers to prove a theorem. It says, we have seen many examples of right triangles that satisfy the Pythagorean theorem. While these examples are convincing, we can never be sure that this theorem works for all right triangles unless we try them all, right? So if you say it works for all of them, you have to actually try it for all of them. That would be a lot of triangles to try this for, right?
Yes.
So, it says to be sure, we make a mathematical proof. We use reasoning to show that the conjecture, just like when you make a conjecture in science, that it's always true. And so I want you to think about this situation as you look down in your notes. It says, for example, if I go on a trip to Seattle and it rains all 4 days that I'm here or there, can I say it always rains in Seattle? If it rained every day I was there and it was never sunny, can I say it rains every day in Seattle?
No.
No. Okay? So, what I want you to put on your paper is this. No, we can't say that. I don't need you to write all of this down that they have up here, but I kind of want you to take a look at it. The same is true in math. In order to see that it works for all right triangles, okay, does it mean we have to show that every right triangle? What we need to do is we need to prove that it always works. And if you go online and you type in proof of Pythagorean theorem, go to YouTube, go to just onto Google, there, like it says at the beginning, 300 plus different proofs that people have proved that this works, okay? Ours are pretty basic. Ours are, we cut apart the puzzle pieces, right? And we can see that the two squares of the legs covered the hypotenuse square, okay? Today we're going to look at these puzzle pieces, and you're going to see that when we look at our puzzle pieces, so as you look at that next part, that if we have a B squared and an A squared plus 4 triangles, and a C squared plus 4 triangles, that this is another way of proving the Pythagorean theorem. So, as we look at this, so this is what we just had to put up on the board. We're going to prove Pythagorean theorem works with all triangles, all right triangles. And the key thing is that notice we were always working with a right triangle when we started this, right? So this triangle that we worked with, this had our A, what I put up, this was our B, this was our C. These were our 2 picture frames. Okay, and it says study one of the triangle pieces and the 3 squares. How do the lengths compare to the lengths of the side of the triangle? And this is what we are really looking at, right? If I have one triangle, so draw a triangle, and we're going to have sides A, B, and C.
Are we supposed to draw that?
Yep, I want you to draw that right in there. So as we are drawing this right triangle right in there, what we are going to take a look at is that each side, A, B, C, if we look at the squares that I had up there, this was the square that had the area of B squared, right? Down here, if we look up at those pictures on either side of the whiteboard up here, this one has an area of A squared. And try and draw as much of a square as you can. And this one is our area C squared. So when we look at our areas, we have an area of C squared, and the sides, when we look at those sides, are sides C, B, and A. So as we go down to this next one, so that's what you're drawing right in that part. Okay? So now as we look at our notes at that next part down, it says, arrange the 11 puzzle pieces to fit exactly onto the 2 frames. So, let's draw what people put up here. Let's draw our 2 frames. So make a square. We're going to draw the first one. That's a square frame. And it is equal. We agree. Those squares were exactly the same shape. Those were equal frames. When your picture, draw it as closely as possible to put the 2 frames. When we look at how this group put their A squared, they put the A squared up here, right, and the B squared, and then they had 2 triangles. I want you to look at the group that did it over here. The group that did it over here in our period 4 class, they had the B squared, and they had the A squared over here. Does it matter? No. Could have put it down here, right? We could move those triangles around anyway. So when we are looking at that, right, let's just draw how we had this one. We had a small square up here, right, which was our A squared. And then down here, this group kind of had, B squared going right below it, kind of like this, right, B squared. And then they had these triangles, right, and our triangles they drew like this. And then they had theirs. Now my drawing, my 4 triangles don't look the same, right? But they actually, we saw when we held up those triangles, all 4 of these triangles were the same. We said that this was length B. This was an A on our picture, right? So put those letters going around. If this is B squared, look up on the board. You can see that right here it has a B, and this is an A, right? This is B. This was A. So going around there, all the side lengths are A plus B. That's what this side is, right? Let's draw our other triangle, and it has that, it kind of goes diagonally, right? So it goes from here to this point, kind of like this, kind of has a diamond shape. That C is kind of a diamond, right? And this is our C squared. And if this is C, then it like shows us on our picture up here that this was B and this was A down here. This was C, this one was an A, this was a B. So that when you're looking at those, right, going around that, we can see that these side lengths are always the same. This was B, this was A. This was B, this was A. So what is still the length of this side? A plus B, same as it was over on the other side. What would happen if I would remove my 4 triangles? I'd be left with what?
C squared.
I'd be left with C squared and what else? C squared in the one frame, right? What do I left with in the other frame? B squared and A squared. Is that proving the Pythagorean theorem? That is exactly proving the Pythagorean theorem. When you go to do this on your test, can you explain this in words? So let's kind of write it out what I'd look for when we do that paragraph, okay? So that you're going to have an idea, how is it that you do these puzzle pieces, and how is it that you're going to show me that you understand what this means, okay? So what we are going to write down is we're going to say the areas of the, since the areas of the frames, since the area, write it with me at the same time, then you won't be waiting and I won't be waiting for you. Since the area of the frames, that was our, that we started with, those outside frames, since the area of the frames are equal in area, and each frame has 4 identical right triangles. Do you agree? Yes. Each one has 4 identical right triangles. If we remove the 4 triangles, the 4 right triangles on each side from each frame, the remaining area has to be equal. Don't you agree? Yeah. The area that remains is equal. So, this is what we started with, right? This one we had an A squared plus a B squared plus 4 right triangles, right, that are identical. They all have the same area. And in the other frame, we had C squared, right, that big square of C, plus, again, 4 right triangles. And we just said, you know, if you think about solving equations, and you guys solved equations last year, you subtracted the same thing from both sides. So I can subtract 4 right triangles here, right? I'm just subtracting them off. And I subtract 4 right triangles here. I like remove them, right? I'm left with C squared equals A squared plus B squared, which is the Pythagorean theorem. And this is what I kind of just need your proof to be, is you explaining how you had these puzzle pieces, or it could be the ones that we cut apart that we did in lesson B1. But that's what I'm looking for you to show me. So as you are looking at that, you start in your homework is we are always going to start with a squared plus b squared equals c squared. Write down the theorem. Do this right now, kind of right in the same spot. As you look at your right triangle here, we need to identify our sides A, B, and C. You're writing this. A squared plus b. There you go. So, first off, where is C? Yeah?
The side of the question mark.
The side of the question mark. C is always the what side? The longest. Hypotenuse. The longest, it's not the leg. It's always across. Okay? So in this picture, C is our question mark that we're trying to find. Where is C in this one? This isn't C? This is C down here? Wait. Where is C?
7.
C is 7. This will be the longest side, right?
Yeah.
And if it helps you in your homework to just put a little right triangle and put A, B, and C. C has to be across, okay? If you don't do it across, you're going to get the wrong answers on many of these, okay? So, yeah, you're still in your notes. Go to your notes on your workbook. That's your problem. Keep your notes open. You ladies are very fine. Okay? So, we are going to put down, does it matter which one of these is A? Not at all. 2 squared plus 6 squared equals C squared. You guys just memorized your perfect squares. 4 plus 36 equals C squared. Some of you will say, well, I like to have the variable first. Well, rewrite it then as C squared equals 36 plus 4 gives us 40. Okay? But we don't want to know what the area of the square is, right? This is C squared. This is area of the square. It doesn't say, oh, I want to know what the area of the square is. It says, I want to know what C equals, the length. So the inverse of squaring is to take the square root. Square root 40 is our answer. If you have your calculator, take it out and we are going to approximate. I want this answer. And then you will notice in the back of the book, they have the approximate answer. Square root 40 was an irrational number, right? So if I put it in my calculator, I know from my work I just did on that last test that it's between 6 and 7, right? 36 and 49. What do you get when you put it in your calculator? Morgan, did you get it?
6.32.
How much?
6.32.
6.32, and then we're going to put the word units. Done. I want both of these answers. Why? Because the first one is my exact answer, which was irrational, and this is an approximate one. All right, so Hunter, we're going to start in the same way. What's the first thing I write down?
Your formula.
Tell me what to write.
A squared plus B squared equals C squared.
All right, Elijah, what are you going to use for A?
4.
4. So I'm going to put 4 squared. And if I use 4 squared, Riley, what is B squared going to be? Question mark. We're going to keep it as B squared then. In your homework, a lot of times they might put an X here or it might be a Y. If they don't put anything and it's just a question mark, then put in B squared. Equals, and then we're going to have Grace Mode, which was, what was C? 7 squared. So now on your paper, 4 squared is 16. B squared, we're going to leave it, equals 49. I need to get this B squared by itself. I got to get rid of 16. We are going to subtract 16. Please show it on both sides of the equal sign, right? This is how you solved your equations last year when you were in 7th grade when you did these. B squared is actually going to be equal to 49 minus 16 gives us 33. That is what the area of the square is, right? This is the area of square B. I don't want to know the area of square B. I want to know the length of B. The length of B is the square root of 33. Approximately equal to 5.74. Is that what we got? and this one again would have units. Okay? Questions? Now, the first page of your homework looks just like these two. It'll have a missing one. What do I want when I look at this? We got one more example to look at. I want you to do this. I want you to show all of these things to get your answer. Oh, Mrs. Thompson, I did it all in my head. I don't need to write that down. I give you the answers in the back. Show your work. I need to see the work to give you credit, okay? Please look at that last one, that last page, okay, that last screen in your notes, okay? It says, using this dot grid paper, find 2 points that are exactly square root 29 centimeters apart. All right, so what does that mean? That is going to be our hypotenuse, right? The hypotenuse is going to be this, square root 29. Let's make a list of your perfect squares. So right by this, put your perfect squares. And I'm only going to go up to 36, right? Perfect squares. List them. First one is what? 1, 4, 9, 16, 25, 36. These are my areas that I'm thinking of for my square, right? These are my areas. Are there 2 of these perfect squares that add to 29? 2 areas that add to 29. Riley, you see one, or you're not raising your hand? You are just stretching. Okay. You see one? What do you see?
25 and 4.
Yep. 25 plus 4. Does everyone agree that 25 plus 4 adds to 29?
Yeah.
So this is the area, right? And now when you do your homework, I just want you to show you that question 4 and 5 are almost exactly like this example. So if you get stuck on 4 and 5, you have a couple options. You can go back and watch the video of us doing this, and you can look at your notes to do this, right? So we got 4, which means what's the side length of the square? Side is 2. And if the area was 25, what's the side length of this square? 5. So I need to have a 5, right? And then a 2. So I need to draw a square with 2. So let's see, 1, 2, 1 more down. Is that going to work? 1, 2, 3, 4. Nope, 1 more. Right? Does that make sense? I need to go up 5, right? And I need to go across 5. 1, 2, 4, 5. Is that 5? Okay, so draw yours. 1, 2, 3, 4, 5. And we have this square, right? This is the square that's 25. Right? Side equals 5. Area was 25. You guys just said that when the area is 4, what's the side length of 2? So we're going to draw over here a square with 2. Some of you aren't drawing anything on your paper yet. You should be drawing this now, so when I go to the next page, you're going to have this down on your paper. So you need to make this great big one of 25, right? Here we have the side equaling 2. Our area was 4. So what's nice about this at this point is I'm going to draw my diagonal. What should the length of the diagonal be? This area over here should be how much? 29, right? We could cut those 2 apart. They should fit on top of that. And if you want to draw that and actually get it exact, that'd be great, but you don't have to, right? You just have to show me these are my 2 points that are square root of 29 apart, right? Does everyone agree that this is the square root of 29 for a side length?
Yeah.
If this area is 29, and so if you wanted to draw this over here, right, this area should be 29. The side length is square root 29. This is the answer, okay? So when you do question 4 and 5 tonight, my hint is, again, if you turn in your workbook to 4 and 5, this is on the second page, is if you think of your list of your perfect squares, which is really your area, that might help you to find the 2 that add to 17, right? And then once you find that, you still need to use the side length, right? So, this is not a hard assignment. I want you to look, though, at question number 3. So, in question number 1, what are you trying to find? A, B, or C? We're trying to find C, right? How about in question 2, what are we trying to find? We're trying to find C again, right? But question 3, we are not finding C anymore, right? In the first triangle, where's C? 7. In the second triangle, where is C? 21. Okay? If you're going to find this first one, we're going to do this one too. Let's do this one together. X squared, right? Oh, so we got to start with A squared plus B squared equals C squared. Okay, this is number 3, right on the bottom of number 3. Make sure you do it below number 3 instead of with number 1. I had someone do it in the last class with number 1, even though we said number 3, and so then they had all the work, but it did make sense for question number 1 because none of the numbers were right. All right, so do we want A to be 4 or do we want A to be X? Does it matter? No. Let's go with A being X. So we're going to put X squared plus B. Oh, but what is B?
B is 4.
4. Equals C squared, which is 7. Okay. We know our squares, so we have X squared plus 16 equals 49. Now here's where I'll have some people say, oh, well this should be 3, because 3 plus 4 equals 7. No. The side lengths don't add together. It has to be the areas of squares. So you always have to square the numbers. When the numbers get uglier, use your calculator. Here we're going to subtract 16, correct? X squared is equal to 33.
Yeah.
X equals, this is the area, right? We don't want the area of the square. We want the side. So when we do this part, we're really finding the side equals square root 33. Approximately. So you got 1 out of the 4 done on your homework on this page, and then you just have those next 2 pages, okay? Or that next page, and then you're done. You should be able to finish the 1, 2, 3, 5 questions with the time remaining. You should be really close if you're getting to work on it. Okay? So get started. The question was, are we getting back